Okay, this is question number 4 from P3 paper, January 2022. And as we can see by looking at it, this is exponential modelling. Okay, so with these questions, they always look a lot more complicated than they are. They're always going to give us some really quite difficult version of exponentials in here. But often when we actually jump in and start doing them, they're relatively straightforward. So let's do that with this one. So we have a quick look at our function and then the information that they've given us. So first of all, A is the surface area of the pond that's covered in this situation. P is just a constant and T is our variable. T is time, the number of days. So when we get given this first piece of information, that the area, 30 meters squared, A is 30, at the start of the study, this is pretty much fairly standard for these sorts of ones, they're going to tell me when T equals 0. So if I do that, and I put that information in, what should happen, I'll do it in a second for you, but what should happen is that I'm able to actually work out what the constant P is going to be. Then the second part, it tells me 50 meters is after T days. Well, because I'll have my P going in there, I should be able to rearrange that and actually work out what capital T is. Right, so we've got a game plan. Let's get started and actually have a go at doing it. So we've just said that for our first bit, we've got that the formula was A equals 80p e to the 0.15t, all divided by P e to the 0.15t, and then plus 4. Looks difficult, but when you've done a lot of these questions, they are relatively similar to each other. And part A says show that P equals 2.4. Well, they were telling me that at the start of the study, when T equals 0, A is equal to 30. So if we put that information in, we're going to get that 30 equals 80p e to the 0 all over p e to the 0 plus 4. And then this is one of our standard things that we know about exponential functions. Anything to the power of 0 is equal to 1, including e to the power of 0. So this suddenly becomes much, much more straightforward because we just get here 80p all over p plus 4. So this is what I was saying before. This is actually a relatively straightforward thing to do now. It looked complicated at the start, but just multiply everything by p plus 4. So I'm going to get 30 p plus 4 equals 80p, which is 30p plus 120 equals 80p. So rearranging that, 120 is equal to 50p. So P works out to be 120 over 50, which equals 2.4, which was what we were trying to do in the question. That's why I showed so many steps there, was because if we're actually trying to prove something, don't jump too quickly to the answer. Make it clear absolutely what that you understand what you're doing. Right, for part B then, part B here, what we're now going to do is, as I said at the introduction of the question, they're telling me that T is equal to T when A is equal to 50, but we already know now that P is 2.4. So if I put that information into the original equation, I get that A is equal to 80. We know P is 2.4. E to the T now, all divided by 2.4 e to the t again, plus 4. Now, if I'm trying to work out what t is going to be, that's what I'm trying to do. Hopefully you can see from here that what I've got is e to the t and e to the t, one on the numerator and one on the denominator. If I can get those so that I can rearrange it to make e to the t the subjects, then at that point I can just take a log of both sides. So my strategy is to tidy this all up, I'm going to do that by multiplying everything by 2.4 e to the t plus 4. But to get everything to a stage, well, let's actually do it. Probably easier to do it rather than say what I'm going to do. So if I multiply that out, I'm going to get 120 e to the t plus 200 on that side is equal to, when we multiply 80 by 2.4, we get 192 e to the t. And this is what I was going to say was, get e to the t all on one side, get everything else onto the other side, and then we should be able to work out e to the t equals. So in this case, if I was doing this, just take the 120 over to the other side there. So I'm going to get 200 is equal to 72 e to the t, which means I can get e to the t. E to the t works out to be 200 over 72. You can put that as a decimal or just leave it like that if you want for the time being. But this is the stage I wanted to get to, because if I now want to get t from this, all I'm going to do is log both sides. Remember, log is the inverse of e, and in the same way as if we had squared, we'd square root. If we had divided by 2, you multiply both sides by 2. In this case, if I've got e and I want to get rid of it, I log both sides. You could write log et, but that would be silly. The whole point is that log and e cancel each other out. So we're going to get t works out to be log of whatever 200 over 72 worked out to be, and that works out to be equal to 6.8. Just go back and check. Find the value of t, giving your answer to one decimal place, and that's a number of days on this part. Okay, so let's have a look at part C. So it says the weed grows until it covers the surface of the pond. Find, according to the model, the maximum possible surface area of the pond. Okay, so just a little exam tip here when we're going through and doing this. If I'm trying to find a maximum or something, am I going to be differentiating and putting equal to 0? Well, no, I certainly don't want to be trying to differentiate that, and then putting it equal to 0 would be quite nasty. How do I know that it's not doing that? Because it's only worth 1 mark. If it's only worth 1 mark, then there must be a quicker version of doing this. The way that I would do it would be part C is if I've got A equals, let's just put the formula down here again so I don't have to keep going up and down with the iPad, ATP E to the 15t all over, and then the rest of it, PE 0.15t plus 4. So the question is saying, find the maximum possible surface area. Well, the maximum possible surface area will be as time goes on and gets bigger and bigger and bigger. And in my mind, the biggest thing that it could get to would be infinity. So this is a little trick that I sometimes do with these sorts of questions, is that I'm going to say that works out to be ATP e to the infinity all over PE to the infinity plus 4. Now, it's this thought process that if I've got pretty much infinity up there, or at least a huge number up there, and a huge number here, adding 4 onto it makes no difference in terms of any degree of accuracy here. So when I take it to be that big, what some people do is say, put in 100 and get ATPE to the 100 over whatever. Anyway, if I do that, the 4 in effect becomes redundant here. And if I do have that situation, I might just put a cross through it. Now I've got ATP e to the infinity over PE to the infinity, and those ones can just cancel out. There are other ways of thinking about it, but I quite like using that technique. So it's quite a nice thing to just get the opportunity to show you that. This is an area of the pond, and it was in meters squared, wasn't it? So let's put meters squared in there. You don't really need any of that in order to get that mark. If you just put the answer of 80, they're going to give you the mark for it. But just a nice thought process going ahead for that one. Okay, hopefully that makes sense.